Hey guys, David, Express Auto again. Today we're going to do something a little different. We've been doing a lot of teardowns and a lot of 4L60s and 6L80s and that kind of stuff. So we've got a Ford in the shop today, which is not a rarity. There's another Ford sitting back there, so we do see a lot of Fords. Not picking on Fords by any means. Love Fords, but this particular vehicle came in with a customer description of a slipping or no reverse condition. You start the vehicle, put it in reverse, doesn't back up. Customer was told that it is a solenoid problem. So, with the knowledge we have of the 4R70 transmission that's in here, we know that in order to create reverse, we need a direct clutch and we need a low reverse band and some splines and a rear planetary, and that's it. So, we're going to show why we explained to the customer we have no reverse, and why it's not a solenoid problem in this case that caused the no reverse.
So you're going to show us how to diagnose it.
Show you how we would diagnose something like this. A lot of shops would just say, yep, no reverse, he's broke. And I'm the same way in a lot of cases. Just by the driving of the vehicle, I'll hop in one, say, Chevrolet pickup, you stick in reverse and they don't go nowhere, take off, and you ain't got no second, no fourth, shell's broke. By golly, we know that one. That's because it's a common problem, we see it a lot, and that's how life rolls around here. So we're gonna put the snap-on scanner on this thing, show you what we're gonna go through and some of the tests that they recommend to do, check the fluid level and that kind of thing. We've already put this vehicle on the rack just so you guys can know that it's safe for us to be underneath. We do have stands around the shop and we will be putting those underneath it for the time that we're underneath it. Currently, we're gonna put it on the ground, get the scanner hooked up and move from there. So, first thing we're going to do is we're going to start the vehicle, pop the hood, and verify the transmission fluid level. Without the correct fluid level, the transmission does not operate. This vehicle is cold, so we're hoping to see the transmission fluid in the cold area of the dipstick. As you can tell, it has a 5.4 liter engine inside of it. So, I'm going to remove the dipstick, wipe the dipstick off, reinstall the dipstick, and check our fluid level. You guys can note that the fluid level is a slight bit low. It's not all the way up to the bottom of the hash marks, but it does state on here that it is in the cold region that it needs to be in. So we do have enough fluid to make it work. I usually like to check it 2 or 3 times just to make sure that I'm getting an accurate reading.
Do you check it in park or?
Check this one in park. So we're going to take our snap-on scanner and hook it up and see what we've got. I'm gonna start with taking the key out of the ignition because that dinger is gonna drive somebody freaking nuts. Locating the OD2 port, which is usually right underneath there. Then go into the scanner, turn all AC functions off. We're going to select a Ford, automatic ID. Some guys don't like to use the automatic ID. I like to use it and verify that the VIN number matches the VIN number we have. And we have the correct VIN. We're going to move forward. A lot of guys like to use the code scan and get all of the codes that are in the vehicle and record them. Sometimes we do a complete code scan. In a case like this, we're going to check each module individually. The main modules that we are concerned with is the engine, transmission, ABS, that sort of thing. So we have 3 codes, a PO 720 output speed sensor circuit fault, and a PO 722 output speed sensor no signal, and a P2106 TAC system forced limited power. So we're going to record those right now. From there, we're going to go to the transmission side. Run a key on to engine off test. No codes present in the transmission side. So we're going to go through and check the ABS, just because that's a module that I have seen issues with that can cause transmission symptoms. No codes present there. We're going to go back to our transmission section. We're going to go to the troubleshooter, and we're going to go to symptoms, tips, driving problems, and see if there are any noted, oh, there's issues in the troubleshooter noted for no reverse. In this section, Snap-on has done a really nice job of giving you different cause and effect scenarios. So, in case you guys can't read it, it says, no reverse condition could be caused by broken sun shell, reverse clutches, rear band failure, drive vehicle in first, achieve 15 miles per hour, lift foot off throttle, and check for engine braking. If no braking, suspect rear band or servo failure. If engine braking is felt, manually shift into second, then to drive. If 1-2 upshift does occur, suspect rear clutch failure or reverse clutch failure. If 1-2 upshift does not occur, possible faulty sun shell, remove and inspect pan for metal, confirm clutch or band failure, remove valve body, and air check clutches and bands. So, everything that this is telling us is that there is not an electronic issue inside or outside of the transmission that can cause it to have no reverse. At this point, we can move forward. We could pull the pan off of it and verify that there is metal or debris in the pan that would suggest reverse clutches, rear band, servo, so on and so forth. We like to take our diagnosis a step further. We're going to remove our scanner. We're going to raise the vehicle on the lift. We're going to raise the vehicle, and we're going to take our transmission line pressure gauge, install it on the vehicle, and record our line pressure, and then we're going to remove the pan. Okay, now that we have safety stands under it, we're going to bring our line pressure gauge over. To install this, we're going to need a 7/16 socket and probably a 13 and 9/16 wrench, or ½ inch. I prefer the 13. So some guys at this point are saying, well, why are we going to all this work? Why are we going to put a line pressure gauge on? We're going to take an extra 20 minutes to do this. The way I was taught and the way that I believe, if you know what you're walking into, it's a lot easier of a fight. We know that reverse is a problem. We also know that reverse takes a lot more line pressure than any other clutch to work. So, could a low line pressure concern have actually caused reverse to fail? If we know that we have a low line pressure scenario, we know more to look at while we've got the transmission out. If we open the transmission up and we don't see any cause of the low line pressure, we need to be checking our EPC, we need to be checking the line regulator valve, we need to check the pressure regulator valve, check the bores in the valve body. We need to do as much vacuum testing as we physically can. or we need to inspect our pump, make sure that the crescent's not wore, make sure that the pump gears look good, make sure that everything is up to the specs that it needs to be. We're going to look at that stuff anyways, but this gives us more definition, more insight of what we actually have to go for.
So you know for sure.
Yep. You know for sure, it's a lot easier to fix it. And fix it right the first time. I would hate to rebuild this thing to find out that we have an electronic issue causing low line pressure, and it comes back in 2 weeks because it's burnt the reverse clutch again. Because not enough line pressure will smoke the reverse clutch. We're going to get us a bucket under here. Going to pull the line tap out. It's going to drip a little bit, and that's okay. Here you go. We're gonna grab ourselves a fitting, 1/8 inch pipe tap fitting. Make sure that we've got the hose out that we want, and the fitting to connect it. That ain't gonna work at all. There's our favorite connector. I knew it was in there somewhere. Somebody took all the fittings out the last time they used it. Need one more wrench.
Do you use this line pressure gauge quite a bit?
I use that thing almost every day. Kind of like an engine guy. If he's building a motor, or he's building motors, he likes to check compression and do a leak down test and that kind of thing. And AC guys, they've got gauges for setting up their Freon and finding out what the system's doing, why it's doing it. Same thing for a transmission. It's all mechanical. Just need to know why it's failing or what's causing it to fail. If you don't know what caused it to fail, odds are it's going to come back. Because if you didn't fix the root of the problem, it's only going to fail again. So I'm a little overboard on diagnosis sometimes. Guys say I spend too much time on it, but when we're done, I can guarantee this transmission and it will leave and everybody will be happy. And that's what we want. We want our customers to be on the road as long as possible. Don't over tighten that case fitting. They break off really, really easily. I've had several employees break them in the past. So keep that in mind when you guys are doing this type of thing. If you guys like to see what we've got going on here, you're more than welcome to scoot on in here, Caleb. So that is our tap fitting. Goes into the line pressure test port on the side of the transmission. We're gonna thread the two fittings together. Now we're gonna pull this guy outside of the vehicle. Reverse line pressure. There are specs in the book that tell you exactly what this thing is supposed to be. So what we're gonna do is we're gonna get our line pressure gauge set where we want it and take some measurements.
So why'd you pick this gauge over the other one?
Well, the biggest reason is that gauge only goes to 100 PSI. This gauge goes up to 400 PSI. In reverse, I expect our line pressure to go well above 150 to 175 pounds.
Okay, I see.
So, need to have a big enough gauge. You cannot put a 25-pound oil pressure gauge on there because it will explode under the pressure. Don't do that. That's a mistake. So now, Caleb, if you want to film our line pressure gauge, I will start this vehicle and in the air, and we'll see what our line pressure does. Great. We have a baseline pressure. What's our baseline pressure, Caleb?
65
Okay.
is our baseline pressure.
We're going to move to reverse.
Reverse is about 130 to 140.
Okay, now we're going to bring the RPM up and see that our pump is working correctly.
So RPM up, went to about 210.
Okay, so we have plenty of line pressure to make reverse work.
Okay.
We're in neutral.
Neutral is back at 60.
We're in drive.
Drive is 120.
And we're going to stall it and drive and see what our stall pressure is.
Stalling and drive was 180.
Okay. So at this point, we know that we have enough line pressure to adequately make this transmission operate. There's enough line pressure for the reverse clutches to come on. There's enough line pressure for our reverse band to be applied.
What'd you say the minimum pressure was?
Our minimum in reverse is supposed to be 115, and let me look that up. Now you got me. Let me go find my piece of paper.
Okay, so I asked what the minimum
The
pressure
minimum
was.
line pressure in reverse is supposed to be 85, and the maximum is supposed to be 280 at wide open throttle. So we're well within the working range of the reverse clutch. So at this point, we know we've got an output speed sensor code. We're going to look at the output speed sensor, see if we have any concerns there. And then we're going to remove the pan and see what we've got there. So the output speed sensor did flash while we had the vehicle in the air and had the wheels in motion. So we know we have some sort of problem because our overdrive light is still flashing. So we're gonna take a quick look at the wiring right there, see if we see any issues, and then we're going to move backwards from there. So our output speed sensor is on the back of the transfer case, and it appears to be connected. Everything appears to be intact. So at this point, we need to get our scanner back on, watch the output speed sensor signal, and see if we have a issue within the sensor itself or the wiring going up to the top of the vehicle. Vehicle speed sensor is attached as well. No sign of anything not attached. And we also know that we've got a output speed signal on the side of the transmission. And I have seen that particular sensor cause other output speed sensor codes. So we're gonna remove the pan, see if we have a whole bunch of metal, and then we're gonna work from there. Personally, I like a bucket with a funnel on it. It's the way I've done it for a long time, and it's kind of stuck with me.
And put it on a tranny jack.
And put it on a tranny jack. It just seems to work for me. So we're gonna get this line pressure gauge off and get the pan off and see what we got. Didn't look like it leaked too bad while it was on there, does it?
Nah, I think it only dripped a little bit.
That ain't half bad. We know we're gonna clean this transmission case whenever we rebuild it, so a few drips is okay. I'll lay this here for now and we'll stick it on the drain rack here in a minute.
You're plugging it back up?
Yep. Put our getting back where it came from.
It's bleeding.
It is definitely bleeding. All right, let's get the pan off of this turkey. Goal is to make as little mess on the floor as physically possible.
And not take a shower and
and not take a shower. The whole not take a shower thing is kind of hard to do sometimes, though.
You ever have like an employee just come out and their whole head is covered in training fluid?
Many, many, many times. I personally was that guy today on a creeper. I actually got my arm sucked up into the wheel of the creeper this morning.
Dang.
And lost control of the transmission pan and made one absolutely beautiful, beautiful mess. Don, if you're watching this, you know what truck we're talking about. All right, so we really don't have a lot of clutch material in the pan, which is surprising. There is some metal debris on the magnet. I would say it's excessive for 170,000 miles. Some guys would say that's not terrible. But we'll see if we can't take this a little bit further. I'll set that pan to the side and see what we've got inside of here.
Can you tell if this has been rebuilt?
It does not look like it has been rebuilt recently, but it definitely does look like it has been out of the vehicle or the motor's been out of it, one of the two. I'm gonna say probably the motor, judging by motor mount bolts. So I don't see any real cause of why we don't have reverse yet.
What are you looking for right now?
Well, right now I'm looking for chunks of metal. I have seen on these things several times in the past the reverse band breaks or valve body gaskets blow out. It's not a super common problem on the 4R70 to see the valve body gaskets blow out, but it is something that does happen. So I say we go cut the filter apart and see if we have enough evidence to move forward and remove the transmission.
Cool. Yep.
All right, guys, we pulled the pulled the filter off and broke the filter open. We didn't find enough evidence for us to be convinced that it's a reverse band. I personally think that it's a reverse band issue, but I've also been doing this a day or two, so we're gonna go ahead and pull the valve body off and show you guys how to fully diagnose if this is a reverse band failure before we rip this unit out and take it apart. So we're gonna pop the harness down off of it. We're gonna put a new harness on it during overhaul, because we're weirdos and always like to replace the harness and the electronics on the inside of the unit because, well, they're 170,000 miles old. So if you're gonna do it, might as well do it right. Put a new harness and new electronics.
What's the cost of a harness like?
I think this one's maybe $45, $50.
So put a new one in.
Yeah, I mean, for the cost of it, why not just replace it? So same thing with the solenoid set. OE solenoids from Ford, I think, are around 35 bucks. So just put new ones in it. There ain't no sense in doing this thing twice. I'd hate for it to come back in a month, throw in a solenoid coat, and we just didn't replace it because we're lazy. So I'm gonna take all the 8mm bolts out here. We like to just put all our bolts in a bucket while we're doing diagnosis like this. There are different length of valve body bolts here. You've got short ones and long ones. Don't get them confused. You cannot put the long ones on the short ones' holes, or vice versa. Always forget that one bolt right there, but we got her today. Getting down to the back here. Let her drain for a minute. It is definitely definitely liquid. I don't know how descriptive we need to be with our transmission fluid, but that is the best gender neutral shift juice I have seen today. So
Cool.
lots and lots and lots of fluid. Well, this one definitely has another issue that we can see right off the bat by getting the valve body out of the way.
What's that? What do you see?
Well, what I'm seeing here is you notice that this E-clip does not have the other side of it. That snap ring right there, that is a super common problem on these trucks. So what happens is...
Oh, the side broke off.
The side broke off
there.
there.
Yeah, I see it.
That side will break off, and it'll get trapped inside of the valve body on the 3/4 sequence valve, and it'll actually cause this transmission not to have overdrive.
And where does it get trapped at?
It gets trapped inside of there. If you want,
Oh, really?
we can pop this servo out, verify we have no reverse, and we'll take that thing apart and show you that problem too, because that is
that servo right there is for reverse.
this one right here is for reverse. We're gonna pop that thing out, and we're gonna lose some serious amount of training fluid when we do it, but that's okay. We don't mind. I'm gonna have to grab a pick. Perfect.
Yep.
Sorry, I'm out of place over there. Okay, we're gonna pop the snap ring out like we said a minute ago. And like we previously stated, this is about to get a little messy, but that's okay. All right, here's our rear servo. Spring is intact, servo is intact. Servo is not broken. Visual inspection of the servo, the seal on the side of it is still pliable. Servo is not cracked or distorted in any way. Now, what we're going to do, we're going to take our favorite screwdriver, we're going to reach up inside of there, and, well, boys, there's no band in that hole.
Okay, how can you tell?
Well,
Because to me it looks like you're just sticking a screwdriver in there.
if there was a band in this hole, when we pushed up like this, it would have resistance. See right there, I can get just a little short piece of resistance. That band should be stroking the entire time. You can also hear that there's a chunky right there.
Yeah.
That band is defective.
Okie dokie.
The rear band is definitely broke. There's our problem for no reverse. Now, let's take this valve body in there and see if we can see why we potentially don't have force. We're going to split the filter and see if we can see any true evidence of where reverse went. To me, I think we have a rear band problem, and knowing that our line pressure is good and that we have a sequence code, I'm going to say we have a problem in the rear band, but never know. We're gonna open the filter and see if maybe there's a chance that there's some material in there that will better explain it. This is something we like to do on a lot of our transmission videos on teardown, actually dissect the filter. One of the biggest reasons why is this thing will tell a whole different story than what the outside of it will tell you. You guys can see right here, this is just a big pile of metal. That's all that is. It looks silver, but it's not actually silver. That's just metal out of the transmission. We're gonna remove our paper here. Sometimes they'll just kind of split. And really, there's not a lot of metal inside of this unit. And we've definitely got some miscellaneous little flakes here and there, but not the amount of stuff we expected to see. So, to carry the diagnosis further, we're going to remove the valve body and see if we can get our rear servo out and actually see what's going on.
Okay.
All right, guys, we are back in here with our valve body. We noticed whenever we removed the valve body and we found that the band was broken like we thought it was, that the clip or part of the servo snap ring for the overdrive band was missing. Part of the customer complaint was that he lost overdrive shortly after he lost, well, no, he lost overdrive about 2 years ago, and he lost reverse about a month ago. So it's been quite some time. I don't think that the two are related, but I think we can easily find where fourth gear went if we take the valve body apart. You guys notice I'm holding my socket. I need some better rings on my tools here. They all fall off. So, if we look carefully, I don't know if we can see it without getting some of this fluid out of here. Let's get some of this fluid out of there. There goes some balls. There's a valve. Now, let's see if we can find our chunk. All right, so our chunk is right there, inside of that valve body. So what this tells me though, is if the chunk is right here and this valve is capable of stroking, he lost overdrive for a different reason. He did not lose overdrive because of this snap ring breaking. But this is something that we have seen in the past cause no overdrive. So if you guys are fighting a 4R70 and you are trying to figure out why you have no overdrive, that little snap, or that little end of the snap ring, can actually travel through this channel and it'll lock right inside of that valve, and that valve will not be able to stroke. If that valve can't stroke, you won't have fourth gear. So we've completely diagnosed why we have no reverse. I feel confident in removing the transmission and tearing it apart and being able to fix it correctly, and that when we're done, we'll have a good product for our customer to drive home. So thank you guys as always. Don't forget to like, share, subscribe, all that fun, wonderful stuff, and we'll see you guys on the next one.